expressions with symbols of inclusion. Now in lesson 4 we learned of the order of operations, the mathematical sequence that we're to follow to correctly solve different type of mathematical expressions. If we do those things in order, we come to the correct answer at the end of our work. Now to add to our understanding of the order of operations, we're going to look at what are called symbols of inclusions. Other ways besides parentheses that you can look at grouping different parts of an expression. Right down here in our new concepts, it talks about how those mathematical expressions can include numbers, variables, operations, and symbols of inclusion. And those symbols of inclusion are defined as fraction bars, absolute value symbols, parentheses, braces, and brackets. And they indicate which numbers, variables, and operations are part of the same term. Here's an example below. Everything inside of this set of parentheses would be considered the same term, even though we've got this symbol that would separate those as plus or minus. So you'd have to try and solve this inside here before continuing to do the operation on the outside. Here's an example of all the different mathematical items that we would use as examples for symbols of inclusion. Here are things that are going to alter our order of operations thinking or prioritize what it is that we're supposed to do. Parentheses, the rounded edge, brackets, braces have that little squiggle line. A fraction bar separates what we do in the numerator and denominator, and then absolute value symbols, they operate kind of in the same way as those parentheses, brackets, and braces. In the examples, it's going to practice how you would actually solve with absolute value first before solving this separate portion of the problem. In this example, it has a set of brackets around your parentheses. First you would solve what's in the parentheses. You solve the innermost symbol of inclusion and then work your way out. So you start on the inside, you would do 6 minus 8, then you would do the 3 added to that value. So here you can see 6 minus 8 is negative 2, and 3 plus that 2 value gives you to what is now outside. Now you're following order of operations. After those parentheses are gone, no exponents, you're moving into multiplication and addition. Again, you're using what would be the innermost part of your symbol of inclusion. Here you have a set of parentheses inside and then brackets on the outside. You would solve the parentheses first. Then you're going to evaluate the exponent because it's still inside of this bracket. Then you can evaluate the entire bracket. So parentheses, exponent, and then the bracket on the outside of it. You're basically working your way from the inside out in that example. Example 3, with rational numbers. So you're going to include any type of fraction. In this case, it asks us to solve the numerator and then the denominator by simplifying the fraction afterwards. That fraction bar separates this into a separate problem and this into a separate problem in the bottom when you're simplifying. In example 4, it asks you to compare expressions, as in you're going to solve what's on the left-hand side with on the right-hand side by using that order operations within the symbols of inclusion. And in example 5, it is using this circumstance with Beatrice buying DVDs marked at a certain price and then given some type of discount or coupon to then reduce that overall price. So you start solving some multifaceted problems here, again by following the order of operations and then factoring in what we learned about symbols of inclusion to keep those things in the correct order. In our Lesson 7 practice problems, we're going to review what we learned in Lesson 4, our order of operations, and then apply our new learning from today's lesson, the symbols of inclusion that get added to how we're going to go through solving a problem in the correct order, in the correct process. Remember, our absolute value looks like and acts like a parenthesis when it's added into an expression, just like the brackets and braces would as well. Here you've got in letter A, 12 plus 5 minus 11. That second portion in absolute value means you solve what is on the innermost portion of that first. So 5 minus 11 is going to be negative 6. I'm going to keep my absolute value symbol around that. You'll see why in just a minute and write down that next step. So I did one step at a time to try and justify that. Okay, first thing is inside of those parentheses are absolute value. Next I need to simplify that. Negative 6 as an absolute value turns into a positive 6. And now I've got 12 plus 6, which equals 18. Notice how I do that one step at a time. When you get better at this, you'll be able to do some of those things, two things in the same step and kind of show that in your work. But until then, I want to make sure we go step by step to have a complete understanding of each of those steps. In letter B, you have two sets of parentheses, and following our order of operations, we're supposed to, with symbols of inclusion, use the innermost symbol of inclusion. Well, here, there isn't an innermost portion, so at the same time, I can do what's in this parentheses and this parentheses and just work myself from left to right. Here I have 8 plus 4, which is going to be 12. I'm going to keep the parentheses there because it has a meaning next to this 5. That symbol of inclusion, that parenthesis, actually needs multiplication when that number is next to it. So I need to continue to keep those parentheses there. In between those, you have a division symbol, so I'm going to drop that down. And at the same time that I solve this, I'm going to solve here with my parentheses. 15 minus 5 minus 4, they're all the same operation, so I can work from left to right. 15 minus 5 is 10. 10 minus 4 is 6. And I keep that parenthesis located there. Now, using symbol of inclusions, you have multiplication happening here in the form of those parentheses being as those numbers are next to each other, those factors. 5 times 12 is 60, divided by 6, and my next step is going to give me an answer of 10. In letter C, I'll move to this side so you can see a little better. See a little better. 5 plus in brackets, 6 times in parentheses, 2 cubed plus 4. These symbols of inclusion have us work at the innermost portion, so we're going to go to those parentheses, then do the brackets on the outside. Inside of those parentheses, our order of operations still apply. So we have parentheses first, then we have exponents. Do the exponent. 2 to the third means 2 times 2 times 2. 2 times 2 is 4 times 2 is 8 plus 4 inside of that parenthesis, multiplied by 6 outside of it. I'm going to rewrite that so that I can continue to work on what would be the correct step. Don't get that confused. Inside the parentheses still is 8 plus 4. 8 plus 4 is going to give me 12. 6 times 12 then is inside of the brackets, which still exist, and I have 5 outside of it. If I don't write those brackets in, you might somehow get that confused to say, well, I need to do this first from left to right, even though this is our multiplication still. I'm going to continue to write those symbols as they go down until I can get rid of those symbols when that problem or that part of the problem is solved. Here you've got 6 times 12, which is going to give you 72. 5 plus 72 is 77. In letter D, in your practice problems, it asks you to justify each step. If you look back at each example problem in Lesson 7, it shows you the solution to how they solve that problem using our symbols of inclusion and the order of operations. And then on the right-hand side, it explains what it is that you're supposed to do. Now, we're asked to do this as well so that our brain is matching what we're actually doing on the paper. We've got this kind of ingrained, and it just becomes a pattern of how we solve these mathematical expressions. Let's model that here, and then I'll have you do that on your own within your assignment today. Here you've got the expression that's laid out, which has a number of different operations and a number of different symbols of inclusion. Symbols of inclusion that we have are a fraction bar, a parentheses with an exponent. So where is it that we're supposed to start? Obviously, symbol of inclusion says the innermost portion, and order of operation confirms that with what would be our parentheses. So I'm starting inside of my parentheses here, and I would say, well, 1 plus 2 is 3. Keep the parentheses because there's an exponent included and multiplication that's going to happen. So you would say, to justify, parentheses. Now, as that's our first step within our symbol of inclusion, let's look at the right-hand side at the same time. Here you've got this fraction bar that shows up as that symbol of inclusion, which means you do the numerator and denominator sections separately before combining those two things based on division being that operation. So we're going to do that fraction bar portion as our symbol of inclusion because both of those would fall into that first step category. Here you've got 8 times 3, which is going to give you 24. I'm going to keep that symbol of inclusion because it has not been solved yet to separate those two. Next, on this left-hand side, I have exponents. I have 3 squared. 3 times 3 is 9, and I would write that like such. So I would say, well, next I need to justify, I thought of doing exponents as my order of operations, and now on this side I don't have any other exponents, so I can move into what would be my next step, multiplication and division. Here I've got 4 times 9 as multiplication. 4 times 9 equals 36. In our fraction bar, we would do the division problem, which is 24 divided by 2, which would give me 12. What's left is the 6, which would go here still, and this division symbol here that has not been used between that left-hand side and that right-hand side. If I did division once, the next thing that I need to do is the division symbol again. So I would justify this step by saying division comes before addition. 36 divided by 6 is going to give me 6, and then I have 6 plus 12, which I'm going to add. 6 plus 12 would give me a total of 18. Now, each example problem shows you this as part of the solution, and Mr. Shane asks you to do this with him here in example D, because as I'm writing these things down, that's what I should be thinking when I'm solving the problem. I necessarily don't need you to write this down every single time you come across one of these problems, but if your thought process is exactly the same because you know your order of operations and you've got those symbols of inclusion in your head on how those fit together with order of operations, then this just lays out, okay, here's why I did this, here's why I did this, here's my next step, and here's why. And now if I compare that to what my notes say and what my textbook says, I've done it completely correctly. Letter E asks us to compare the expressions, as in we're going to solve using our symbols of inclusion and order of operations on the left-hand side and then on the right-hand side, and then put those two things together, seeing which is greater than, less than, or equal to. I like to work on the left-hand side first. We've got a number of parentheses and brackets. Here's how you'd go about solving that. The innermost portion would be the same for either of these until when you look inside that symbol of inclusion, you see that there are other operations that you should do first. For example, here you've got just addition, here you've got multiplication and an exponent. Exponent goes first, 2 times 2 is 4, then I have that multiplied by what would be inside of that same bracket. Mr. Shane is going to grab a different marker because that one's not working very well. Keep this thing rolling. Here we go. 2 times 2 is 4, times 5 inside is going to give me 20. In my next set, I have addition. 13 plus 5 is going to be 18. That's in parentheses. Minus 20. 18 minus 20 is going to give me negative 2. On the right-hand side, I've got a number of different operations. I'm going to start on the innermost portion and work my way to the outside. Innermost portion of this bracket is this parenthesis. We've got 7 plus 11. 7 plus 11 is 18. Then I've got minus 5 happening. Technically, I can get rid of those parentheses because I've solved and eliminated that, but I'm going to solve inside of that bracket now. 18 minus 5 is going to give me 13 minus what is now outside 2 cubed. You said, Mr. Shane, doesn't exponents come before that? Not if there's a symbol of inclusion, which I'm solving the innermost portion. It doesn't necessarily affect it here. I can still solve this before I'm going to do this subtraction. So 2 cubed is 2 times 2 times 2, which is 8. 13 minus 8 is going to give me 5. Which one of those is larger? Alligator eats the larger number. You can even draw these fancy little teeth in here. Nice. He looks hungry. He looks happy. And the alligator is going to eat 5 as a larger number because 5 is larger than negative 2.